Hello, everyone. Getting ready?
Hello.
Hello. Uh, there's a little bit like 2 minutes to go. So let me welcome everyone. I hope to start at the session at exactly the time. So welcome to session 4.2 CDIO implementation. And it seems that all of the speakers that we will be taking questions after the video clips are already here. In this session, we will have 4 papers in particular, focusing on learning progress monitoring. Yeah. So briefly, because today is first day, so let me recap a little bit about how we will do it. I will start by introducing the speaker, and then we will together view a 7-minute pre-recorded presentation, during which, should you have any comment or question, you can silently submit to the author or to me, but to everybody would be easier by the chat feature in the Zoom. After that, we will have an open session of Q&A, by which you can use raise hand feature in the Zoom to raise a question. Yeah. So we probably will start the session within 40 seconds or so. For the first paper, should I wait 30 seconds? We have like 25 participants in this session already. So let us wait for 20 seconds. All right, for the first paper, let us welcome Mr. Mark Wan, specialist and senior lecturer from School of Electrical and Electronic Engineering, Singapore Polytechnic. So we will show your video first, right? And then we'll take the question a little bit after the video. So let's start the video for the paper number 41.
Hello everyone. I am Mark Wan from Singapore Polytechnic. Today, my colleagues Yuki and I will present to you our paper on maximizing students' learning through learning analytics. Here are the contents of the presentation. We will first be covering the background of the ALERT project, and the research questions framing this paper. Before moving on into the methodology, where we will walk you through the real-time student feedback process. Lastly, for the results, we will present the sample dashboards, the implications for practice, and the student's experience of ALERT. So, what is ALERT? ALERT, an acronym for Assessing Learning in Real Time, is a joint initiative by the 5 polytechnics and Institute of Technical Education to create a technology-driven framework that incorporates the application of educational technology tools and data visualization software to facilitate learning. In particular, this research explored how students experienced specific interventions in real-time learning, such as the use of readiness tests and an exit poll, through the use of learning analytics, which captures, analyzes, and presents students' performance data in a visual dashboard. The scope of research is as follows. The School of Electrical and Electronic Engineering implemented an ALERT strategy during COVID-19 circuit breaker, where students were primarily in a home-based learning mode. The module involved was a first-year module, Digital Electronics. 19 staff and 1,211 students were involved. The specific research questions asked were the following. Firstly, can the use of learning analytics provide a more precise diagnosis of students' learning in real time? Secondly, does an evidence-based teaching approach, and selected EdTech tools, enhance student learning? The methodology involved quantitative and qualitative data on the student learning experience during the project intervention strategy. The process steps are as follows. Firstly, the student attempts the quiz in EdTech tool Socrative platform, before online class time. Secondly, the student completes the graded COVID-19 formative assessment quiz, in Blackboard in the online class. Thirdly, the student completes a short exit poll, 30 minutes before the online class ends. And lastly, the lecturer analyzes the data further via the Power BI dashboard, and takes immediate intervention actions. The sample dashboard provides a visual data representation of student performances through the use of pie charts, graphs, and a word cloud. The key purpose here is to identify if students require further help with questions, so that the lesson plan can be adjusted to address the student's need. A sample dashboard for the exit quiz analysis is also available. The key purpose here is to assess students' perceived level of understanding of the lesson in real time, in order to help faculty identify which topics required further clarification, and use some of the remaining time to address this learning need. As the dashboard data monitors students' learning in real time, one such implication which we have thought to highlight here is the ability to identify more precisely and efficiently student learning gaps and misconceptions. Take for instance a learning situation where students may not prepare well for pre-class activities. Using specific examples from the Power BI visualization, it was observed that a student had only scored 50% in the pre-class quiz, and rated himself 3 out of 5 in the perceived level of understanding. Through that, the faculty is able to step in and take the necessary actions, enabling the student to improve. You may refer to the table for the full explanation. Here is another example of another learning situation, when students perform poorly in pre-class tests, but overestimate own level of understanding. A student scores 25% in the pre-class quiz, but rated himself 4 out of 5 in the perceived level of understanding. Then similarly, faculty can step in this case with task-specific questions and positive feedback, and monitoring performance of the student over the instructional period. This eventually leads to a positive impact, as the student subsequently scored 62% in the CMST. On the other hand, there are also learning situations which we need to be aware of as well. In this situation, the student had scored 50% in the pre-class quiz, and rated himself relatively high in the level of understanding, scoring 9 out of 10 in his CFA2 quiz. The student had also asked concept questions, which gave an impression that he had understood. However, the student subsequently scored 31% in the CMST. While it could be that the student may not have been well prepared, it is a reminder that this situation should have been monitored more fully as well. This sums up the summary examples of using the dashboard for real-time pedagogic interventions. Moving on, we present the summary findings of the student's experience of using this learning intervention. Overall, the percentage of students who rated extremely and very useful for the pre-class quiz was 64%. And the percentage of extremely and very useful students for the exit poll quiz was 44%. In conclusion, this paper has outlined a pedagogic intervention, initiated in response to the challenge of providing effective and efficient online learning in the COVID-19 pandemic. The research suggests that learning analytics, when employed from an evidence-based teaching approach, can play a significant role in using EdTech affordances to maximize student learning outcomes. As student performance was not measured, their perceptions cannot be corroborated in terms of meeting specific learning outcomes. This was, in part, the result of time pressure to get the intervention moving quickly in the context of rapid school closure. These are areas for future improvement in both methodology and scope. With that, we have come to the end of the presentation. For more information, do refer to our paper. Thank you.
Right, thank you very much. Anybody that now we get to the Q&A session. So you can type in to the chat features, or you can raise your hand. And if you do so, can you also introduce yourself?
I wish I can do a live demo. See the real thing. Seeing is believing.
Right. Alert, right?
Yeah.
Yeah, that's what I heard.
Because it's so difficult to visualize. Is it once we have the Power BI chart, pop it up, and we can monitor every single student and so on. That's wonderful.
Yeah, right. I believe we have one question from Karin.
Right.
Please introduce yourself a little bit for us.
My name is Karen Stenderup. I'm from Aarhus University in Denmark. Thank you for a very nice presentation, Mark. I was wondering, when you have more than 1,000 students, how do you adjust your teaching? Could you provide an example of that? Because there's a lot of students to adjust to. I reckon.
In our cohort in the first year, I'm teaching them digital electronic. I'm not teaching them so-called 1,000 students together, right? So I have around 20 students for each class. So we have around 20 staff to do all this. So this how we monitor the so-called student is we try to catch the at-risk student. I mean, for those students, they are at risk, they don't understand. So they are supposed to, we tell them to do some study before they come to the online class. So they will do some quizzes. So we can get the data before they come to attend our online classes. We got the data already. From there, we know what they know and what they don't know. From there, we adjust our teaching schedule there. Also, during the so-called 1.5 hour teaching, there be half an hour before the end of the lesson, we pose them again. I mean, we do ask them to do a quiz. You catch ball or you don't catch ball for the last 1.5 hour teaching. So some of them, they will answer. After all this, right, after they give me all the feedback, I just run the Power BI and the data of so-called readiness quiz and also the exit poll quiz. They will pop up to the chart, so I can see who is a student don't catch ball and who is a student they catch ball. Yes, this is how we do it. Yeah. So you are talking about, so at the end of the day, we also get some feedback from the student. That is after everything is over, so called toward the end of the semester, we give a big survey, qualitative, quantitative survey, and ask them to give us some feedback and so on. So for myself, I'm using evidence-based teaching. That's the pedagogy I use. And then I compare with my other colleagues. I don't know whether they are adopting the EBT same as me. So we just compare some data and so on. What we are doing now, we are continuing with this project, but doing it in a much bigger scale. We are also employing RPA to help us because it's very complicated. So-called all the staff, they must master the so-called Power BI technique and how to get the Excel file and put it to the chart. It's quite not so user friendly. I mean, the staff must have the knowledge. So what we are doing now, we set up a team, so-called RPA team. So the staff just one click, two click, boom, the thing will pop up to the chart. So this is our we are already successful doing that. So that will be our next paper to share with everybody. Hopefully we can see each other face to face and we can demonstrate all this. Yeah. Thank you.
Yeah. So next year is in Iceland. So
we pray hard that this epidemic will go away and or we come up with very powerful vaccine can
right
can heal all this.
Yeah.
Thank you.
Yeah. So we have a time for a very short question. Sorry, anyone have some? And actually, because for this session we have 4 papers. So if you came up with a question for any paper, we have 41, 68, 70, and 27. You can leave the question for the presentation, for the presenter, and so we can catch up with that a little bit.
I will get back to you to whatever question y'all post me. Yes, time is
please.
so limited.
That's very limited, but hopefully you can put it your question in the chat also,
That's
or
right.
maybe a little bit later in the Whova application.
Right.
Of
Great.
course,
Great.
don't forget that.
Yep.
Yeah.
Yep.
Thank you very much,
Thank
Mark.
you.
Yeah.
Thank you.
We got to get to the next paper. So next will be the presentation from Nicolas Serrano. He is a professor of language and computer systems at the School of Engineering at the University of Navarra, Spain. I personally am using Flip Classroom, and I would be interested to learn more about automated assessment. So let's listen to their work. Paper number 68.
Continuous assessment with flipped learning and automated assessment. In this presentation, we are going to see how a continuous assessment system has been implemented in a programming subject. For this, we are going to see why we use a continuous assessment system, the codes tool with which it has been implemented, and the results we have obtained. We start with the continuous assessment. Why a continuous assessment system? The literature shows that continuous assessment provides better students' performance. Basically, because it forces them to spend more time on tasks. It's also the experience we have as teachers. If the students don't reach the desired level, we increase the number of evaluations. This happens, for example, with the implementation of a new curriculum. It starts with a single final exam, and we increase the testing with the mid-term exams or exams more often to motivate the students to bring the subject up to date. The main disadvantage of this continuous assessment is the increase of time involved, because the correction of these exercises is necessary. In this case, we see what was happening in the digital technology subject in 2016, in which there were two evaluations on February 26th and April 15th, which were the assessments that were carried out in addition to the final exam and the project of the subject. And in this presentation, we see how we have moved to an evaluation in which every day that there is a class, there is either a practice test or a theory test. This means an increase in the correction load, and that is why the use of an automated evaluation tool is necessary, which is the codes tool presented below. This has led to development that have occurred since the 2016-17 academic year, in which a practice was evaluated every 10 days. The following year, with the good results obtained, we moved to a weekly evaluation, which remains in place to this day. In the 2019-20 academic year, flipped learning was introduced. This was before confinement, and this is what has followed in the 2020-21 course, also including interactive quiz in Teams. The change to weekly tests occurred because this provided a routine for the students. They knew that according to the schedule, every Tuesday there is a practice assess, and every Friday there is a theory test. So from the first or second week, they already know what is the routine that they are going to find in the subject, and they get used to work in this way. As this test and practice only make up a small part of the grade, and it is also a grade that can be recovered either in the partial evaluations or in the final exam, they are tests that do not suppose great pressure for the student. However, if they pass them, they are securing this grade, and many can achieve a passing grade before the final exam, because in reality they already know the content of the subject. The codes tool has been developed to automate the assessment of the students. In this tool, the teacher defines on the one hand the questions, that is, the items in codes, in which he describes a theory or an exercise and defines how it is going to be evaluated. In this case, in a programming application, is going to be evaluated by executing the code developed by the student with some arguments and expecting some output values. This exercise that the teacher defines in this way, the student is going to see it when the student makes a notebook that contains several of these items in the form that is presented here. In this case, it is asked to write the factorial function so that when it executes, it returns the value of that factorial. Here you enter your code, which will be tested by the application. The system executes your code, gives you the result, indicates what the score is and the total score you can get, and in which attempt you are of those defined by the teacher. In this case, it is indicating that there are 8 possible attempts, and this result is saved in the application. The teacher of this subject has defined Java exercises, exercises to develop web pages, to program a simulator of a processor, JavaScript exercises, and web application development exercises. The Codes tool has different modules to test these and other types of exercises and get the result. What was the result with the students? The result has been obtained on the one hand from a survey of the students in 2 different years. They were asked if they prefer to have this weekly evaluation. Here we see that 96% did want it. If they wanted to have the practice exercises also evaluated. Here again another 87% wanted it, and in total 100% did want some of the weekly exercises to be evaluated. So we think this is a good response from the students. And in this other graph, what we saw is the participation in different tests that the students have had. We see that almost all the area is blue, indicating that most of the possible tests has been done by the students. The teacher has different ways to see the results of the students. For example, in this case, each row is a student and each dot is an exercise the student has done. If we look at a column, we see that it is the result of this particular item for each of the students. With this information, the teacher can see the situation of a student and the class. Thank you very much for your attention.
All right, so it's time for Q&A. So Professor Serrano is already for the question. Anyone can raise hand. Go ahead, Professor Serrano. If you want to add something from the video to the video.
Yes, you have a more clear explanation is on the paper, and also in the link in the YouTube. Also, you have the subtitles. You want more details about the elements, and if you want also some details about the application, in this case, we can contact and explain how we have do and how we can implement it in different courses.
Mm-hmm. I saw one person raising hand. Could you start by introducing yourself? Oh, Karin? Oh, yeah, sorry. Yeah, go ahead.
It's just me again. So, Nicholas, all these weekly tests, you said that they play a part in the final evaluation, the final grade. Is that true? Could you elaborate on that?
Yes, it's voluntary. If they don't take this weekly test, they have the final exam as the complete mark of the course. But if they take this weekly test, it usually is 5.5 points of the mark. So if they do the 10 tests that they have in 10 weeks, they can get half of the mark of the class. We have a complete or 2 sheets explaining the evaluation methodology because it's complex, because we have a lot of tests and exams, and we want to allow the students that if they fail something, they're able to recover. And for this, we have some rules that allow this. It's voluntary, but if they perform well, they can get the mark before the evaluation.
Maybe I have one question myself. I put it in the chat box such that you can see the example for everyone. If you want to have your question asked, you can put into the chat box. I just wonder. I find that your automatic correction tool, a particular, you seem to be quite confident in it. If you have any particular supporting evidence about that.
We say that the evaluation is automatic, so they get the result immediately, they make the answer. In fact, we allow different responses because as the questions is make a program, if they fail, they are able to modify in the time they have in the SAM. But if they do something and they think that the machine has corrected badly what they have said, they had written, they usually what they do is to send an email to me, and I manually correct. Most of the time is to say which is wrong, but we always have a manually validation if they think that there is something bad. And this is also very interesting because the people that send this email, they are the students that have some problems, and you are able to localize them in the first weeks. So usually you have questions in the first week and you don't have any questions after the SAM.
Yeah, I got that. Next, Junji.
Yes,
Please
hi,
introduce
I'm
a little
Yun
bit.
From Singapore Poly, Singapore. Very interesting presentation. Thank you for sharing. I have two questions, quite unrelated. So my first question is that, do you find that although your tests are graded for students who take it, right, do you find that participation kind of drop nearer to the end where the exams come? That's my first question. For the second question is that how many attempts do the students are able to do for each test? Is it unlimited or is it only one attempt? And do you, sorry, third question, sorry. Yeah, sorry. And do you find that the students, how to say, would they near the end decide to more of them go for the exam instead of doing this weekly test, or the other way around? That means as they progress through, they find that the weekly test is better for them to help to score the marks. Yeah, sorry. Yeah.
Yes. About the first question is when they got the subject passed, if they fail to go to the class. Yes, it was at the beginning one of the problems that we think it can happen, but in fact, we have seen the opposite, that the people goes to class to the end because usually after 3/4 of the class, they have get the mark to pass the subject, but they see that they can get a very good mark because the methodology helps to know the subject quite well, and they are confident with the subject, and it's a subject in which they want to get a very good mark, and they go to them. We also provide an option to make the SAM previous to the final exam, because as we use flipped learning, we have already material, and 3/4 of the class prefer or they opt to make the exam 3 weeks previous to the final date. And usually these students, they have already the class pass and they had a very good mark. And also the number of tries in the exams of type programming, we provide as many, well, not as many, we provide 6 or 7 trials for each one of the exercises, because here what they see is I'm able to solve this type of question, but not the next one. So we provide, or yes, we allow to have multiple essays. In the test, not. In the test, they also have only one result. Is solved? All right.
Thank you.
Thank you for the question.
Yeah, all right. Thank you very much. Yeah. So again, if you have any more question about paper 41 or 68, you can still type in the question into the chat box or using the Hua application. So the presenters can get to the question and can answer your question a little bit later during the second day or third day, or even later. Okay, we get to the next paper. The third paper will be presented by Kevin Calderon. He is a PhD student, graduated in telecommunication engineering, also from the School of Engineering of the University of Navarra, Spain. Okay, let's take a look at the video together. Paper number 70.
Data analytics of students' continuous assessment activity data. In this presentation, we are going to describe the analysis of the data retrieved from students in a computer programming subject after the introduction of continuous assessment. The presentation will be divided in 3 sections. In the first one, we will give a brief introduction of the topic, the application of data analytics methods in education. In the second section, we will describe our process in order to develop a model to predict the final grade of the students. In the final section, we will present the results obtained with the definitive model. Now, we start with the first section, in which we will mention the benefits, drawbacks, and barriers of the application of data analytics in the field of education. The main benefit of data analytics in education is that it provides new insights about the educational process, allowing access to information that wasn't available before. These insights allow to improve the teaching-learning process, as teachers can take decisions based on this information. One example of application is the prediction of grades and performance of the students, which is the one that we use in the research. In addition, data analytics allows the measurement of the quality of the learning process. On the contrary, we should be particularly cautious using the data analytics methods in education, as the data is always related to people. Students could change their behavior when they know information related to their performance. Finally, the barriers are related to data collection and standardization. We usually work with data stored before thinking in their analysis, so we usually waste time organizing the data to obtain a proper model. As we mentioned, the second section is model development. It is divided in 2 parts, data preprocessing and model fitting. In this slide, we can see the format of the data obtained directly from the tool we use to implement continuous assessment. It shows the information of each student's answers to each exercise. From this original dataset, we only retrieved the user ID, which was previously encoded to preserve the identity of the students, the mark, and the max grade of each exercise. From another database, we also retrieved the student's final grade in the subject. Now, this slide shows a table with the final dataset after collecting the data. We replace the missing values by 0 and normalize the grades between 0 and 1, which is helpful to develop the model. Here, each row shows the performance of a student in the course. With this data, we can plot the course progress of any student. As you can see in this figure, each blue cross represents the grade of an exercise. The red line represents the final grade of the student, and the green lines represent the estimation of the final grade with the grades obtained until that moment. Here we show a figure that compares the actual final grade and the predicted final grades of 13 students. The prediction is accurate in most of the cases, except in the second and in the last one. This figure shows the course progress of one of these cases. As we can see, the student stopped answering the exercises at some point in the course, which means that the student dropped the subject. So we decided to make a comparison of the models obtained with and without these students or outliers. The scores in this table show that the model that doesn't consider the outliers has a better prediction. so we decided to use this one. At this point, we described the entire process to obtain our final model. So in the third section, we will present the results obtained with the developed model and make some conclusions. In this slide, we present another table which compares the scores obtained when we introduce different numbers of exercises in our model. We choose 3 different cases. In each case, we selected the exercises from the beginning of the course until reaching a percentage of the exercises. The percentages were 25, 50, and 75% of the course exercises. If we take into account more information or exercises in this case, the prediction will be better. This happens when we compare the 25 and the 50% cases. However, this rule is not fulfilled in the third case. We can notice that the 75% case has worse results or scores than the 50% case. Our guess is that a student's behavior is more unpredictable at the end of the subject, probably because students are more focused in other projects and evaluations, which led to overfitting in the model. Thank you for your time and attention.
All right. That's a presentation from paper number 70. And Kevin Calderon will be taking your question. Karen, please go ahead.
Kevin, thank you for this nice presentation. Do you use your results during the course to change, just like Mark did? Do you use it to change your teaching during the course, or do you grab the students and have a talk with them? Or I mean, do you use these results to intervene with the students during the course?
Hey, Karen. Well, all our analysis was made after the course. So we didn't use the results to make some changes in the methods or in the treat with the students. But well, that is our approach in this next course. So we will show you results.
Okay, thank you very much. Any more question? Like I said, actually, I use also the flipped learning, but admittedly, I came from mechanical engineering, so really hard to catch up with computer programming to solve things. Okay, I think. Oh no, it's Karen.
I just have another question.
Yeah.
Kevin,
oh yeah, sure.
Elaborate a little bit on the time. How much time do you use setting up all these tests and questions? There must be a lot of work behind it.
Yeah, well, the questions they are made at the beginning of the course, and it depends on the kind of the question that you made, because maybe the test-based questions just you need like, I don't know, 15 minutes. But if it is a programming question when the students have to insert the code, you have to make a lot of tests in order to avoid that some problems with the correction. And I don't know, it's like half an hour maybe for each exercise. But the good thing is that once you made it, you have it there and it's corrected automatically for all the students. So in that sense, you like save some time in the future, you know.
Mm-hmm. Yeah. I think you have quite a big plan to step forward about this project. Yeah, that's very good. Looking forward to hear your next step about the next conference as well. Thank you very much, Kevin.
Thank you.
Yeah. So I think let's get to the next paper, paper number 27. This topic is really important for today's pandemic world. It's about the self-directed learning. Yunji Wong, who is a teaching and learning mentor, will be present this work that came from her team at the Diploma in Chemical Engineering, School of Chemical and Life Science, Singapore Polytechnic. All right, video number 77.
Hi, my name is Yun Yi, and I'll be sharing a little of what my colleagues and I at the Singapore Polytechnic have been working on, which is the transfer of self-directed learning competency. Self-directed learning is a very important 21st century skill. When we are self-directed and able to extend the self-directedness to learning other things, we become lifelong learners. But it can be quite difficult to transfer self-directedness from one context to another, as many factors affect the development and transfer of this SDL. This includes self-confidence, experience, and even the environment we are in. So the Diploma in Chemical Engineering, or DCHE for short, is a 3-year full-time course. Our students come from different backgrounds and have different academic abilities. They also have no relevant technical background when they join us. So our curriculum is designed in a way to let students progressively develop their knowledge and skills they need. So where they have to learn the fundamentals in year 1, revisit them in year 2 in more depth, and again in year 3. Self-directed learning is also woven in the curriculum in this similar, progressive, and integrated manner. So in year 1, semester 1, when students first join us, we introduce intrinsic motivation and growth mindset, 2 important factors needed to develop SDL. We then teach the steps involved in SDL using the DCHE SDL model and the thinking heuristics in year 1, semester 2, and also provide guiding questions to help students apply SDL in learning. These guiding questions are gradually reduced as students progress through the years until they are expected to apply SDL independently in year 3. SDL is integrated in the curriculum through 2 pathways. Firstly, through structured learning activities in practical-based modules in year 1, and then through project-based modules in year 2 and year 3. Through this integration, students can develop other skills they need, such as lab investigative skills, process operation skills, and also CDIO skills at the same time. Students can then use these 2 pathways to transfer their SDL competency from structured learning activities to managing a chemical product design project, and finally, to the real-life work environment during their internship. So when students move from using SDL to managing a chemical product design project in year 2, they naturally have to become more self-directed because projects by nature requires more self-directedness than structured learning activities and practicals. At this juncture, we also provide less scaffoldings to students so to allow them to slowly gain more control and responsibility over their own learning. So about 64% of the students surveyed found that SDL was useful and important in managing projects. More than half found their previous SDL experience useful. This suggests that they were able to refer back to the original context where they learned SDL in year 1 and then transfer their learning to managing their projects in year 2. In terms of scaffolding, nearly 50% of the students expressed that they made use of the guidance question when they had to manage their project in year 2. So this suggests that the questions were useful. But interestingly, about a third of the students did not use the guiding questions at all. Perhaps these students do not need the guiding questions anymore, or they are not ready to take control of their own learning. When students progress to year 3, they will intern at a local company and complete work tasks and an internship project. All of these are company specific and will reflect the varied nature of their placements. So students will have to use SDL to manage and learn company-specific new materials needed to complete their projects and work tasks. So all these are much better indication of SDL transferability in real work environment. More than half of our students surveyed said that they need to find and learn the new materials needed to complete their work tasks and projects. And all found their previous SDL experience that they learned in school during year 1 and year 2 useful. We also asked students what they did when they had to learn these new things for work in order to find out whether they were able to truly apply the SDL skills during their internship. Responses collected from the students surveyed showed that most were able to plan, monitor, evaluate their own learning while managing emotions at work as they had to learn new things to complete their work tasks and projects. So this shows that students had characteristics of a self-directed learner who had transferred what they learned from school to the real-world workplace. So to conclude, our Year 2 students seem to be able to transfer the SDL skills taught in structured learning activities and practicals to managing a small group project. Most students in Year 3 were able to display characteristics of self-directed learners in the workplace, and these results are encouraging. But there are also some challenges, because SDL by itself is something complex to measure and determine. It also requires quite a lot of self-reflection to develop further, and the readiness level will change as situation environment changes. For students to develop into self-directed learners, we also find a need to balance the amount of guidance provided and independence we want to let students have. Because too much guidance, students will then not take up responsibility over their own learning. And too little guidance, students may then give up. So for future work, we plan to convert some practicals to e-versions, and this will allow them to apply SDL because e-learning itself also requires some form of self-directed learning. We will also continue to study and develop SDL and enhance its transferability. Thank you.
Thank you very much. Karen, you go first.
Okay, thank you for a very nice presentation, Yonyi. I was wondering, so is this something you do extracurricular besides the topics, besides your courses, and when the students participate in this SDL, and how much time would you reckon that they spend on it? So is it part of your lessons or is it besides the lessons? And how much time do you think the students spend on it?
Thank you for your question. Yes, time is a very important factor because, curriculum has limited time. So because of that, we actually weave it into our curriculum actually. So in our practical activities, for example, we actually look at the practical activities, look at the learning outcomes, and based on which activity is the most appropriate to interweave SDL, and we actually put in the questions to guide the students to, for example, plan, apply, monitor their emotions and evaluate together. So it's all interwoven. So students not only do the practical, so learn all the laboratory skills and other skills that they need, but they also together develop their SDL skills. So this is how we did it. Yeah, so no extra curriculum time spent actually. Yeah.
Wow. Yeah, thank you. Any other question? In the meantime, I have one question. I think the transferability is very important. Just wonder how different the transferability for the SDL compared to other professional skills or competencies in your view?
You mean how to measure?
I mean, in the CDIO standard, we will have the what you call the integrated curriculum that we need to really stepping up their learning and the capability.
Yes.
Yeah, but just wonder when we want to have the student have the project management skills or the critical thinking competencies, all those things, we need to really have them build up their competencies.
Yes.
But how do you see the difference between those skills and these self-directed learnings?
I actually see that they are the same, because for this self-directed learning, it's also progressive building for the students. This is our actual first run. The results that we present is of one whole cohort of students that went through year 1, year 2, year 3.
Yeah,
so we are continuing this study, and we find that students, when they are in the lower years, they need a lot of reinforcement. So we guide them along, and we actually determine which level should they display it. Then in the second year, we expect them to be a bit more independent to apply the self-directed learning. So therefore, we will remove, for example, some of the guiding questions along the way, and incorporate more self-directed learning into a more general, project-based activities. Rather than, the very small structured activities where we provide scaffolding questions for every single practical that we actually want to develop. Then in year 3, we effectively just, prompt them along the way, but mostly is on their own. So throughout, we actually think through at which level they should be for the different years.
That got me thinking, because you suggest that you kind of pulled out the scaffolding as time went by. Very interesting. And then I just thought that we keep that scaffolding and trying to have them engage from the first to the last year, but you see that you got to take it out a bit by bit.
Yes. We take it out a little bit by bit, so that they still have the similar framework to fall back on, but it's not so guided in a way already. So eventually we can just totally remove it in third year, because when they go out to the companies for their internship, we are not by them all the time. They are in a work environment, although we are there to provide support, but by then they should be already more self-directed in that sense. So that's why by then we decided that they should not have these guiding questions anymore. But we still have the template for them to fill up, saying that, maybe from this week to this week, look at what you have planned, for your project, what you want to do, then after that, how are you going to evaluate? So there's still some form of guiding, but not the questions already, they're specific to what they're actually doing.
Very interesting approach.
Thank you.
Maybe I have really one thing that in your paper that really struck me is about what you mentioned about the diverse socio-economic background and different level of interest of student. Because when we look at our student, look at the difference in the background, we don't really expect that we can really deploy this in the majority of the student. Just wonder what kind of what aspect of the result that really convinced you that we can do it for the whole cohort.
Okay. The thing is, because we don't take SDR as a standalone thing, we put it together with activities that they are supposed to do in the curriculum already. If we take away the SDR aspect, they are expected to complete these activities anyway as part of learning through the curriculum. So therefore, we look at that and say, okay, how do we weave SDR into this? And of course, for different students, there is a different level of, readiness and the results that we see. And even within each of the group in the practicals, we see that. So that is our another challenge, whereby how to bring all the students up to the same level. So within the small practical groups, you need a lot of facilitation to see, okay, maybe member A, B, C, D, maybe member C and D are not so ready. So we are able to provide those interventions along the way, but as we move to the later years, like internship and things like that, is a bit more difficult to do that. So that's another area that we want to look at. How do we actually bring everybody up to the same level?
So are you saying that you look into the student and try to characterize them into groups? And just wonder.
Okay, for the practical activities where we first start to teach the students about SDL itself, they are the students are already grouped into groups because they are doing, the hands-on practicals. So they always stay in these groups for the semester itself, the entire semester. So we are able to observe them within the group context, how they answer the questions and things like that. Moving ahead, in the second year, when they move into projects, they are still in groups, but of course in different groups. Then we are still able to provide this type of support to them. But when they go up to internship and things like that, then it will be a bit more difficult because we have students going out to the internship, they have different projects, you know, they work with different companies. So that is a bit more difficult to provide the support. Yeah. So our challenge was in the group base. Firstly, it takes a lot of facilitation from the lecturers part, you know, to provide the same sort of support because, you know, our cohort is quite big, you know, each class is about 20, 25, you know, and there are 2 lecturers involved. So, you know, to go through each is a bit difficult. And if students are a bit resistant to this, then that's also another challenge, you know, but yeah, we are trying to see how best we can actually push everybody up to the same level before they actually go out to internship. Yeah.
I got your point that you're trying to weave this SDL into the project that students already familiar to, the activities that they are already kind of expected to complete. Yeah.
Yes.
Yeah. Thank you very much.
Yeah. Welcome.
Yes, we have time for a few more questions. And of course, you should try to use the Hoover because when you goes through the event, you probably might come up to with a few questions, and you can leave the question to the presenter, and so we can continue. I think for this session, for almost all the papers came from the project that will be going on for quite a bit, so we can continue to engage into this kind of study, and we can share the result together for the next regional meeting or even international meeting. All right. I think that the time for this question has ended. So thank you very much for your participation, everybody.
Thank you.
So take a quick break because the next session will be the poster session. It's just a fun time to listen to the 1 minute pitching. Yeah. So thank you very much, everybody, and see you in the plenary session. It will be a plenary session at session 5. Okay. Thank you very much.
Thank you, Dr. Anki.
Thank
Thank
you.
you.